So to find the equation of a tangent line at x equals -2, we need to find the coordinate at -2 as well as the slope at -2 to make an equation of a line, a tangent line. So the first thing I want to do is find the coordinate at -2. So that's fairly simple. I'm going to come over here and simply find f of -2, which would be -2 minus 3 squared, which looks like to me would be -5 squared is 25. So I have a coordinate of -2, 25. That is a coordinate, that is a dot. We now want to find the slope at that point and put those together to make an equation of a line. So next step is I want to find the slope at -2. So to do that, we are going to have to maybe do this first, x minus 3, and you're going to want to do the FOIL to get that into a polynomial shape. So when we do that, we have f of x equals x squared minus 6x plus 9. Now we're going to take its derivative. F prime x is equal to 2x minus 6. And then, didn't we say we want to find the slope at -2? So we want f prime -2, which is 2 times -2 minus 6, which looks like it's going to be -4 minus 6 is -10. So can we come over here and write m equals -10? We have a coordinate and a slope of -10. I want to now make an equation of a tangent line, an equation of a line. Now, we're going to use point slope formula because the AP test uses it more. Here's point slope. It says y minus y1 or y2, I'm going to put y1, equals m times x minus x1. They like this formula versus y equals mx plus b. It's easier, actually. Because watch, here's what you do. Y minus, what's y1? Well, isn't that y1? Isn't that x1? So can I simply do y minus y1 is 25 equals m, which is -10, x minus x1, which is -2, and I'm done. You don't even have to simplify. There's your answer. That's an equation of a line in point slope format. Now, could you configure that to slope-intercept if you had to? Yeah. But just be aware, they tend to like this on AP tests a lot. But they'll also do it in slope-intercept form. But I think this is an easier way to write the function and get used to it. Because we're so used to y equals mx plus b, I'd rather focus on this one because it's the one we're not as commonly using most of the time. So this is the equation of a line at -2, that is a tangent line at -2 to this function. Where does g of x have a horizontal tangent line? So where is this function, what x value has a horizontal tangent line? Well, when I say horizontal tangent line, that means slope 0. So what we're really asking for here is where is the slope of g equal to 0? That's really what it's saying. So to do that and find it, don't you first have to find the derivative of g? So let's find the derivative of g, which this is a pretty easy one. That's going to be 2x plus 8. So aren't we now saying, okay, when does 2x plus 8 equal 0? Isn't that what we're asking for? When is the slope equation going to equal 0? And we solve that, which is a nice linear equation. So minus the 8 over 2x equals -8. Divide by 2. So x equals -4. So at -4, this function will have a horizontal tangent line, which that actually does mean that at -4, g of x, since this is a parabola, will have a vertex. This would be the max or min, which for this one's a happy parabola, so this is going to be the minimum vertex at -4 of the function. And -4 is where that is, that vertex.